All right, guys, welcome back to Heiko's Garage.
Yeah.
As you can see, it is airhead time again. I have currently 3 in my care. 2 of them are mine, and this one is owned by a friend of mine. And I'm just going to do some maintenance on this bike. Needs new tires, needs a few little things. So since I have so many airheads to take care of, I like to have the right tools for the job. You guys probably in the past have already seen a video about the harmonizer, which is a electronic vacuum gauge, so to speak, that you can use to synchronize carburetors really well. And you can also find the highest idle on a carburetor to adjust it properly so it runs the best. There's one thing that I've always been lacking, which is getting the mixture just right. Of course, you can find a mixture, the idle mixture adjustment, the right spot by just listening to the bike. So you will always have a RPM increase, then a drop off towards the rich side, and then you will have, turn it the other direction, you will have a RPM increase and then a drop off to the lean side. And you try to find the middle spot, maybe make it a little richer than middle, just to be safe. But you still don't know exactly if this is a proper air-fuel mixture. So the stoic point of air-fuel ratio is 14.7 to 1, which is 14.7 parts of air to 1 part of fuel. That's the stoic or the perfect mixture. On air-cooled engines like these all are, you want to go a little richer than that, because a richer running engine is a little cooler running engine. So for the sake of longevity of those airheads, you don't want to go with a stoic point. You go maybe somewhere between a 12.5 to a 13.5 air-fuel ratio, so 13.5 parts of air to 1 part of fuel. If we would start talking about the different types of fuels that you can get, so ethanol-free or E10, which has up to 10% ethanol in it, this air-fuel ratio mixture setting changes a little bit, but that would go too far for this video, and there's tons of information about that out there on Google to be found, or YouTube even. What am I talking about? If you want to get a carburetor, let me get a carburetor real quick. So if you want to get a carburetor adjusted correctly, a lot of testing will have to go into it. This here is a 32 millimeter Bing carburetor, which originally was mounted on my R90. I have since switched to a set of Mikuni carburetors, which I'm still working on to get the jetting just right. How you can identify a CV or constant velocity carburetor is by just looking at the top. If you have this large round top which houses a big diaphragm, then you have a constant velocity carburetor. When you pull on your throttle handle, on your throttle cable, you are actually not physically opening the throttle. You are just opening and closing a butterfly valve in here. I don't know if you guys can see that. It's kind of dark, huh? So I'm opening and closing this right now by hand. That's what you're moving, a butterfly valve. But the actual throttle slide in the middle and the throttle slide needle is controlled by a diaphragm. So you're not directly controlling the throttle, but indirectly. If you want to get this carburetor to run at its peak performance, best horsepower, best fuel economy, and a just overall smooth and good running engine, you have to get 3 circuits just adjusted correctly. In this carburetor is what's called a pilot circuit or an idle circuit that controls the idle RPM and up to about 25% of your throttle. Then the next 50% of throttle movement from 25 to about 75% is controlled by the needle jet and the throttle needle or the slide needle. Here in this case it's a round slide, open and closed by this large diaphragm. At the bottom of that round slide you have a needle, and the needle goes into the needle jet. that needs to be set up correctly. There are a few things that can be done. You can change the jet itself, you can change the setting of the needle, and you can even change the needle shape. And manufacturers make all kinds of different needles and whatnot. And then you have the last circuit, which is the third in this lineup, which is the wide open throttle main jet. So when you're over 75% to full throttle, the main jet, which is at the bottom of the needle jet, that controls that mixture. And all those three circuits have to get the air-fuel ratio just right. So if you are aiming for, let's say, a 13:1 ratio, you have to achieve that with a pilot jet or idle jet. You have to manage to have the same, well, a similar ratio all the way through from 25 to 75% of your throttle movement with the needle jet and the needle. And you have to have the same air-fuel ratio or somewhere thereabouts with the main jet. Some people say you want to have the idle a little richer, so when you're idling somewhere at a light, it's not running as hot. Also, when you're going from idle right into halfway open throttle, so you have a little bit richer mixture at idle, so when suddenly the throttle comes open and a lot of air rushes through until the airflow is established and the air speed in the carburetor's venturi, the venturi is pretty much the air passage of this carburetor, then you have a little bit richer mixture at idle to compensate for the sudden onset of air rushing in, so you're not leaning it out too much and it's falling on its face. There are lots of methods. Someone's riding past. Lots of methods to get this all adjusted. A lot of old guys, they can do that by ear. Of course, everyone can hear a change in RPM when you're playing with your, here in this case, we have, here's a mixture screw right at the bottom of this carburetor. This is a fuel mixture screw. Some carburetors have the mixture screw on the other end. So this is towards the engine, this is towards the air filter. If the mixture screw is towards the engine, it's a fuel mixture screw. And if it's more towards the air filter side of the carburetor, then it is a air mixture screw. So when you're changing the setting of your mixture screw, you can hear RPM changes, and you can find the spot where the RPM is the highest and the engine runs the fastest. That's easy to do. Where it gets really complicated is to really know if the air-fuel mixture that this carburetor at idle produces is somewhere in the range that this particular engine needs. There are some methods to figure out how that, or if that's the case, which is, just to mention one of them, is reading the spark plugs. So you would park your bike, you ride it around, get it warmed up, you park your bike, you put some fans in front of it, because remember, this is a air-cooled engine. You can't idle standing still for very long, or you might overheat your engine. So you want to put up some fans, get some airflow going, and then you stop the engine real briefly, put some brand new spark plugs in, and then you idle the engine for 5-6 minutes, and then stop the engine, pull the spark plug out, and you can look at the spark plug and see if the fuel in that air-fuel mixture has given the spark plug some color. If it's way rich, you will have a really dark, black, sooty looking spark plug. If it's very lean, the spark plug will look like it's brand new still, because only the combustion of the fuel in the air-fuel mixture actually stains the color of the spark plug. But that is also topic for a lot of debate, and what the spark plug should really look like and what the color should look like, and you can never get 100% a readout, okay, this is equivalent to 13:1 air-fuel mixture. You can see if the engine overall is idling well, and you can hear that, and you can see, okay, it's not sooty black and it's not super clean white looking, so it's not running too lean or too rich, but you can't really get a numeric readout on the air-fuel mixture. When you then switch from something that is stock to a certain engine, so on my R90, this one was stock, the manufacturer Bing, they have a manual, and in this manual you can look up specific to your model. Like, let's say I have an R90 from, yeah, here's an R90/6 with this carburetor here. This is the 643211, and I can look exactly what slide I have in there, what main jet size, what needle jet size, what jet needle I'm using, atomizer, idle jet, and so on, and can look up what the stock jetting for this carburetor is. And then I can, if it's not correct, I can change it back to stock, and then I can tell myself, okay, with a stock jetting, these CV carbs, they can run anywhere. Some people believe that just because the throttle is controlled by vacuum rather than by your throttle cable, these somehow compensate for altitude changes. And I don't want to say this is completely incorrect. They are more forgiving. Let's call it that, okay? Because with altitude, the air density changes. So everything is always, calculated starting at sea level. At sea level, you have the most dense air. And there is what's called, in aviation terms, it's called a standard atmosphere, which is 15 degrees Celsius, and a certain air pressure. And that is sea level pressure. Since all those motorcycles made in the 70s were assembled in Berlin, I don't know exactly what the elevation, ground elevation in Berlin is, but it's not in the mountains for sure. It's not at sea level either, so it's somewhere in between. So they probably in the factory, they found out, okay, this R90, 1974, runs with this carburetor, with this specific jetting, and they wrote it in a little spreadsheet here. And that's what the jets are that they put into the carburetor at the factory. And then they just delivered them all over the planet and sold them everywhere. And it didn't matter if this motorcycle would be operated at sea level or if it would be operated like here in the Sierra Nevada mountains. So my house is 4,700 feet, which is, let me think, 1,000, let's call it 1,500 meters above sea level in metric terms. So pretty high up, not quite on top of a mountain, but we're at the foot of a mountain, yeah? So this carburetor was designed, put on the bike, jetted by BMW in Berlin with a jetting that would work in Berlin. And then just because it's a constant velocity carburetor, which is more forgiving to changes in altitude, it will run here pretty well. I can tell you for sure, as you go up in altitude and the air gets less dense, you will have a richer and richer and richer mixture. So when I go over the highest mountain pass that's here near my house, 8,900 feet, let's say maybe Berlin is at 900 feet above sea level, suddenly we're 8,000 feet higher than that. That means the air is significantly less dense. There is less air molecules or oxygen molecules in a cubic foot of air than at 900 feet in Berlin. And therefore, this carburetor doesn't get the air-fuel mixture correct anymore. There is a little bit of some forgiveness because of the vacuum control of the throttle, but these are also not impervious or self-adjusting carburetors. That's a misconception that is out there on the internet, but a lot of people believe that, and they ride around with a stock setting from Berlin from 1974 all their life, even though they live in Colorado, somewhere high elevation. Even these can be jetted and should be jetted for elevation. Let me put this out of my hand now. And to solidify my point, even here in this Bing carburetor and throttle bodies manual, they have a section here where you can do a main jet correction chart. So density of air does not just change by change in elevation or altitude, but it also changes by temperature. So the hotter the summer is, the less dense the air is. So if you're on a hot summer day in the mountains, that's like worst case scenario. So you can look up your outside air temperature and your altitude in feet in this little chart here. If you don't own one of those manuals, you should definitely get one. And then they give you a somewhat of a percentage. So let's say at 86 degrees Fahrenheit at 6,500 feet, you can correct your main jet size by a factor of 0.93. 1 would be the size that's currently in there. So my main jet is what's my main jet stock? 150. Factor of 0.93 is 93% that size. So you divide 150 by 100, that's what, 1.5, and then times 0.93, and then you get your new main jet size. The same calculation you could do with a needle jet and with the idle jet or the pilot jet, you know, for what it's worth. Not very many people do that, so they just ride around. The bike, you know, it copes with it, it handles it, it's acceptable. But if you want to get your bike running at peak performance, you either have to, you know, do the spark plug reading method, or you go the route that I'm going to be introducing here to you right now. So if you're into cars and motorcycles, you have probably heard the term air-fuel ratio, air-fuel mixture, and then they sell air-fuel mixture gauges that you can install in the dashboard of your 1963 Mustang. You can do that, or you can buy yourself a tool that's not mounted anywhere, that just gets used in a shop setting. And this particular one here has actually been on the market for like 12 years, so it's nothing new. This is a tool made by Innovate. Let me take this out of the packaging here for you. So this is a little tool. It's called the LM-2 by Innovate. Is that correct? Yeah. LM-2 single oxygen basic kit. So what this thing does is it measures the oxygen content of your exhaust gas, and it gives you a readout in form of air-fuel mixture. This tool is also what's called in the tuning world a data logger. So you can hook up all kinds of different sensors. You can hook this up to a modern OBD2 port in a car. This can also read error codes in your car. So this is a code reader. You can delete codes. It can read any sensor that a modern vehicle has installed via the OBD2 port. So you can get coolant temperature, engine temperature, intake air temperature, fuel pressure, oil pressure. All those things can be logged in this little device. And then later you can take this device. It has a slot for an SD card. You can take this SD card to your laptop. They give you a specific software, and then you can put all the readings, all the temperature graphs into a certain format, so you can look at readouts from your engine. It's a live data logger. So you can drive around with this. You don't even need to look at it, and it does that all in the background. It's called a O2 sensor or O2 tester because you can hook up a, let's grab it here real quick. It comes in the kit with a wideband oxygen sensor. What is a wideband oxygen sensor? Yeah, it's a sensor that measures the oxygen content in your exhaust gas. And every modern car, really modern cars, have multiples of those. So they measure the oxygen content before the catalytic converter and after the catalytic converter. And the data that this provides in form of a voltage signal gets put into your ECU, your electronic control unit. And that gets a chance to adjust the timing for the igniters and the ignition based on the signal from those oxygen sensors. Like every modern vehicle has one of those. Every vehicle that has fuel injection, or most vehicles that have, I should say, most vehicles that have fully electronic ignition and fuel injection system nowadays have oxygen sensors. So anyways, with this little test tool, like I said, you can get readings from all kinds of different sensors. You can rig up your own sensors. I also bought a inductive clamp that I can put on one of the ignition leads on my bike here, or on any bike, on the ignition lead of one of the cylinders to get an RPM signal. Just like with your timing lights usually use an inductive clamp as well. This can be hooked up, then this oxygen sensor, and then you can actually mount this on your bike. Here is a power cord which uses a normal, cigarette lighter type outlet to power this whole thing off of a 12-volt battery. And so you could hook this up, tape down the wiring, secure everything, and then you can ride around, not even paying attention to this little screen here, just ride around, do your testing, maybe let it sit here for 5 minutes so you get 5 minutes of idle. Then you can ride around 20 to 75% throttle, which you can mark on your throttle handle, and see what your air-fuel ratio is while you're in your mid-range, while you're using mainly the needle jet in the needle. And then you can maybe do a couple short bursts of full throttle up a mountain road, maybe uphill. That always helps to not go too fast. So you can really open it up and get readouts on your air-fuel ratio at full throttle. So pretty much that's what this thing can do. Logging all the data, then later you take your SD card out, go to your laptop, throw it in there, start the software that you can download from Innovate Motorsports, and then look at the results. And then you can look at graphs, see what's developing. You can see air-fuel ratio idle, air-fuel ratio mid-range, and then air-fuel ratio full throttle. And then you can draw your conclusions from it. So let's say your idle is sitting at a 15:1, which 15 is on the lean side of the stoic point. The stoic point is 14.7:1. Am I even saying this word correctly? Is it stoic? We don't want to be stoic. So just in case I've been saying this word incorrectly, so the stoic, not stoic, it's stoic, point 14.7:1 at, I guess, ethanol-free pump gas. We're talking about the stoichiometric air-fuel mixture. Isn't it nice that, German speaking, trying to speak English and then getting it all wrong, talking about someone being stoic. Anyways, so if the number gets higher, so 15, 16, 17, that's getting leaner, whereas 13, 12, 11 gets richer and richer and richer. Let's say you are now at an idle of 16:1, you know that your mixture is too lean. And the only thing that you can really try is change the setting of your mixture screw. And if that doesn't give you the desired result, then you have to increase the size of your pilot jet or idle jet. So you have to go up in a number in your pilot jet size. And then you have to run the test again to see what that change did. Do I have to now readjust my idle mixture screw, which you most likely will have to do. Then you run it in the mid-range, 25 to 75% of throttle movement. That's roughly where the needle jet is used and the needle adjustment. And again, let's say this time we're really rich, we're like 11:1, and you want it at 12.5 to 13.5, somewhere in that range. So you now need to get this leaner. You can either go down a size in your needle jet, or most needles that are inserted into the needle jet, they have little clips at the top, like a little E-clip. If you raise the needle by lowering the clip down, you are enriching the mixture. Or if you raise the clip lowering the needle, that will make your mixture leaner. So if let's say we're at an 11.5:1 and we want to get it a little leaner, you would raise the needle, drop the needle, raise the clip, like one clip or two. If that's not doing it, then you have to get a smaller needle jet. And then last scenario is the wide open throttle. You are riding around uphill, third gear, wide open throttle for just short sections so you can get a readout. And you notice that your mixture is way lean. So you have to get a larger main jet. Or it's really rich and then you have to get a smaller main jet. This is only possible if you either have a air-fuel ratio, air-fuel mixture gauge that you actually have to look at while you're riding. That's kind of the downside of this whole thing. So you're in traffic on a public road, revving your engine, going uphill, and you have to stare at the gauge to actually see what the readout is. Or you use this one here. They are getting cheaper and cheaper. They used to be $400 or $500 when they first came out in like 2010. Now 12 years later, this is kind of old technology, old display. The data logging is still very usable for any kind of tuning purposes, but yeah, they are now about $250, $280. And you can do data logging. It just has a record button here, red record button. It records everything while you're riding, and then you just look at it after the fact. Much safer, much better. What I want to do now is make two things. I want to make an adapter. So my power cable here, which uses the normal standard cigarette lighter outlet, adapts to the standard Dean outlet that the BMW motorcycles always had back in the days, which is a smaller size receptacle. So I'm going to make an adapter that this plugs into, and then the adapter plugs into the Dean outlet on my bike. Then I can power this thing. And then the last thing I want to do is, oh yeah, I want to mention this real quick. So here in this kit, you have a long sensor cable for the oxygen sensor. So you can run it from, let's say, the tailpipe of your car into the vehicle and put the thing on your seat, for example. I don't know how long this is. This is 8 feet long only, so maybe you could run it from your tailpipe into the rear window of your car or the bed of your truck, something like that. They make longer extension cables for that. They also give you a bung, which is a steel piece that this oxygen sensor threads into. There's also a cap. So if you would take this bung and you would weld it onto one of your header pipes, you would need two in this case because you would want to check both carburetors. One carburetor is kind of servicing only one cylinder, so you have to test both. So you can either use a couple of those bungs, weld them on your header pipe, then when it's not in use you put a plug in there, and every time you want to check if your carburetors are still jetted correctly, you can take the plug out and thread your oxygen sensor in, and off you go. Or what I'm going to do is I'm going to make myself a exhaust, kind of a sniffer adapter pipe, which is just going to be an 18-inch long piece of water pipe, 3/4 inch, that I will weld this bung onto, and then I can stick this piece of pipe into the back of my muffler. So completed the welding of my water pipes plus bung for the oxygen sensor and my clampy piece here. This might need to be some, maybe need to modify this, cut the handle off or something, or completely do something else. But for now I have a sliding piece here on this puppy. So now I can insert my probe as far as I can into my exhaust, or maybe the short end, depending on what's better. I guess I'm going to use the long end here. Have my clamp on here in the right orientation. And then I might find some material that I will put here on this little clamping part, maybe some self-fusing silicone tape that's heat resistant. Just put a piece of silicone in between there. So, and that will hold this whole probe in the pipe. I can also still shorten this pipe if this sticks out too far. I mean, there in the rear, it really doesn't get in the way of anything, so it shouldn't be a problem riding like this. I just want to make sure it doesn't fall off. Maybe even when I'm riding, put a couple bungee cords or ratchet strap or something to the frame here. Once this is tight, I don't think this is going to come out. And I'm not going to ride to San Francisco with this. So just back street with the oxygen sensor sticking out, the wiring all going forward. Now we just need to make the power adapter, and then we can look at how this is all going to get wired in here. So quickly soldered together. Yeah, my shrink tubing kind of broke already. There's not really any strain relief to speak of, but I think for a 12-volt application that is only going to be used a couple times, I think it's going to be fine. What we're going to do now is just to verify that our connection is correct. We're going to go to... Oh, is my battery dead? No, no, no. Oh, man. Isn't that always perfect timing when your multimeter suddenly gives up? Let's see if I have another one. Nope, no, not readily available. What else can we do? Yeah, I don't want to use my brand new test equipment there to find out if the polarity is correct. Let's just find a new battery. I'll be right back, guys. All right, guys, I'm back. I got a new battery in my multimeter. Hey, anyways, Fluke, if you ever want to sponsor a channel, I could use a better, So let's do continuity, it beeps. And I just want to make sure that the center pin here is connected to the, I don't know if you guys can see, there's a center as well. And we just want to make sure they are connected. And now I'm going to touch the other side, and that's good. And now I'm going to touch the inside of the receptacle, and we have continuity. Okay, so that's good. All right, let's go and see how that all mounts on the motorcycle. Alrighty, guys, so here it goes. As I already showed you earlier, with this little clamp contraption here, we can shove a pipe. I might shorten this a little bit, to be honest. This is maybe a little overdoing it, but yeah, I can shove it as far in as I can. Then I will find myself some, protective something, silicone, cut it out of a heat-resistant baking sheet of my wife's, like the corner. Put that in between so I'm not scratching up the chrome. Then I can crank this down a little bit. So now let's get the wiring all out. So then we use the oxygen sensor. I'm going to keep that protective cover when it's not in use. You want to put some not dielectric grease, some never sees on there. Tighten it up so it's gas tight more or less. There's some gasket, just like the same gasket you find on spark plugs. Then we have this long 8-foot cord, sensor cord, that just plugs together. Let me see if you guys can even see what I'm doing here. So this goes together. Those are watertight connectors. And then let's go and then you can probably zip tie this on the bike here, secure it on your grab handle or something so that it doesn't fall off. Let me grab some other parts. I switched to another bike, by the way. I don't know if you guys noticed that, but my project bike doesn't have the DIN outlet currently, which of course this is gonna get fixed. The DIN outlet is not a cigarette lighter outlet, so you can't put a cigarette lighter in it, but it's pretty nice for just a 12-volt connection. So they still make it, they still produce parts for it. This is a RAM mount that I don't use for my cell phone anymore. And I think we can probably make this work here somehow on this puppy. Maybe here this little hump. If we go around the hump, can we? This is gonna work. Maybe a little on the small side. Let's just put it in here for now. Maybe I can modify this RAM mount a little bit, make the arms a little wider, bend them open a little bit. Or change the little rubber bumpers that are on there. Kind of like that. All right, so then, let me grab your handheld here. So that's there. That's there. Wiring 8-foot harness needs to go to the front somehow. Then let's come around here. all those straps that really don't need to be here. Here is the outlet. So now this is 12 volt connected. Now we can take the power cord that Innovate gave us. That is I don't know, a few feet long. So now we can plug this in. That has a fuse in it, so we're not blowing up the device, but rather a fuse if anything goes sideways. We can also tape that together somehow. And then this puppy, the other end, goes to, ouchie! Yeah, that goes right in here. I don't know what you guys can see. Oh, there's power. They always say not to hot swap connectors. So if your oxygen sensor isn't connected, then just take power away. So 12 volt, that's already working. Now we're going to hook up the oxygen sensor. Here at the back side is a diagram that shows you which connector. There are more connectors down here than what we currently need, and it's that one. So one down here is the proper sensor connector for the oxygen. Sensor number 1, there you go. So and now we can plug the 12 volt in. Then this puppy should do kind of a self-test real quick. See if you guys can see that even. So now it's heating up the oxygen sensor. And then once that's done, we can go to mode 20.9. 20.9 is the current oxygen value in the air. That's very accurate, so we might not have to calibrate this. Multiple sensors can be hooked up. Here, calibrate sensor. We go to calibrate, press enter, start calibration. And now it's calibrating the sensor. And then once you get a 20.9, you're right where you need to be. So now I just have cables tangling here, which just for a test run at idle, I want to at least tie together with one of those wire ties here. And you know what? I'm going to go and get my inductive clamp as well. I don't want to shortchange you guys and not show you the whole deal. So we have power, all the cables are out of the way. Let me pause you here real quick and get the inductive clamp. So now we have the inductive clamp from Innovate. It's like an accessory to the LM2. They of course sell the LM2 as a total complete kit that comes with all the wires. I don't know, it doesn't say which side needs to go to the spark plug, so I don't know if that's really important. Now we need to take that off here. We need to power down the device. So we remove 12 volt. Now I have to find out where that goes, the inductive clamp, and we're just going to clip it on the spark plug cable here. So let's see. I guess I have to take it off my ram mount one more time. Oh, here's clamp. It even says that on here. I don't know if you guys can see. Clamp down here is the outline power, OBD2, sensor 1, analog I/O. So you have quite a bit. Here's also an in and an out. It also has a USB port. This is a micro USB port, a little old-fashioned, but you get the idea. That's for transferring the data over to your computer. And it comes with that cable too. So now really the only thing that's missing for my setup here, I only bought the basic kit, is a whatchamacallit, a OBD2 connector. So now we have the oxygen sensor hooked up and the clamp for our ignition signal. Power it up one more time. It will do the heating up of the oxygen sensor. Please remember that this motorcycle is cold. It's going to run with choke, so whatever we're seeing, the air-fuel ratio is not going to be accurate at all. So heating up, and then it should switch to the display of the oxygen sensor here pretty soon. Now I'm going to take everything off the bike that doesn't need to be on it. Get the key. And I have secured the cables so that it doesn't go anywhere. At least I hope. With my little wire ties here that came with the thing. I want to look into the menu one more time. I think it was mode. Yeah. So fuel type, enter. It's gasoline. Yeah, you can go LPG, methanol, ethanol, diesel. Okay, we don't need that. Display lambda, RPM, enter, enable. Okay. Let's go to mode one more time. Okay, to cancel. Oh, there's configure RPM. I bet you analog input 0. I don't know. Inductive clamp, enter. Rising edge, I don't know. Polarity, rising edge, I have no idea. Failing edge, rising edge. Let's just leave it the way it came. And that's it. And now we can literally try to start up and see if we see anything. Okay. Key. Battery is good. Fuel. Choke. Good. And excuse for my reach around here. That's really rich. That is, but that was to be expected. It's really cold. It's not running very smoothly. So far my contraption back in the exhaust hasn't fallen off yet. I can smell the unburned gas. This is really lean. What am I saying? High number is lean, low number is rich. That is, maybe that's a wrong number. So this is mid-range, 13.2, that's pretty good. That's pretty rich. That's pretty rich. Something's smelling funky here. Maybe it's the pipe that I stuck in there. And do we see an RPM here? No. Why do we not see RPM? So they say that at idle, it's pretty difficult for the oxygen sensor to pick up a good reading. And as we go up in RPM, you see that it goes to a normal range. We'll have to play with that a little bit and find out if I can really, get a good reading at idle. But at least for now, we know that most everything works. RPM, enter. Okay, let's... I don't see any RPM. Maybe it's just to... Oh, let's do mode. Yeah, 1440. That might not be correct. Yeah, this is not correct. That's twice RPM. Configure RPM. Inductive clamp. Falling edge. 1 pulse per rev. That's more accurate. 800, 750, 700. That sounds about right. Gotta play around with that sensor back at the exhaust. I'm gonna turn it off. I don't want to overheat my air-cooled engine here. Yeah, the problem is that when this thing is running at idle, that we don't get sufficient exhaust gas flow through that pipe. So maybe we have to install it the other way around. Let's see. Kind of like that. So it doesn't get exposed to external fresh air, only get exposed to the exhaust gases. Okay, like that. Tight. Let's see. I'll turn it on one more time. So now it's heating up the sensor again. Every time you crank the battery, I guess the voltage drops below the normal voltage. So yeah, idle, I can't really not get a good reading here. At idle, it's showing us 26. That's very, very lean. So it's still a project. It's not done yet. Microphone on, yeah. Okay, so it's still a project. I will have to work on this exhaust gas sniffer pipe a little bit, but at least we have it all hooked up. We have a way of wiring this together, and we can at least mid-range and full throttle do some mixture testing or air-fuel ratio testing, and then maybe adjust the jetting accordingly. And I can do that on both cylinders. So first I do one, get that all correct, and then do the other one. Or do test runs with both sides, but that would probably be really confusing. Ultimately, it's probably whatever changes I do on one side will be the same on the other side to just keep it even. You're not gonna run 150 jet on one side and 155 on the other side, right? But yeah, reading the exhaust gases during idle, that is now going to be the question. How we're going to make this happen so that the oxygen sensor is happy. And yeah, the pipe just doesn't go any further in there. There's only so much room in this muffler. I wonder if that has anything to do with it. But I figured that if I shove it in all the way, so it's up against the opening back there, that it loses as little of the exhaust gases as possible and then get a accurate reading. But nobody knows, right? But my clamping mechanism here, at least, it holds onto the muffler. kind of like that. Yeah, that is kind of a shame, but I will play around with it. If you guys are interested in the LM2, any of the equipment that I have here, I will try to find some links, put them down below in the description. Also a write-up about the spark plug method, how you can get your mixture correctly. Maybe a link to that Bing manual. Everyone should have one of those. And then you can play with your own Airhead. Alrighty guys, if you like this video, give me a thumbs up. Subscribe to my channel, please. Help me out to get motivated to make more videos for you guys. Alright, see you in the next one. Bye. We're at 13, 14. That's relatively normal. It's a little on the lean side, I would say. So what I managed to do is, first of all, I tighten up the sensor in the thing so that it wouldn't leak here. And then I managed that my clamp actually closes up the muffler, and the only way that exhaust gases can escape is now through the pipe here. And yeah, and so now we're actually getting a normal reading, 14, 13.8. That's pretty normal. So I can maybe even do something with some sort of putty, exhaust pipe putty, temporarily seal this off when I do the idle testing. And then I guess while I do high-speed testing, you don't want to add too much to a restriction, so I can remove it and then it breathes a little more freely. But yeah, this is pretty promising. And I could also potentially extend the length of this pipe with some silicone tubing or vinyl tubing to make it longer, to have less oxygen be sucked back in. Because it's pulsing, you know, it's always pushing out, sucking in, pushing out, sucking in kind of deal. And so oxygen would enter from this direction. If I make this pipe longer, the oxygen would have a longer travel to go to the oxygen sensor. But yeah, so might also have to cut this loose one more time and change the angle a little bit. But for now, it looks pretty good. So overall, we got it hooked up in a way that functions. The idle reading, yeah, good question. I'm going to play with that a little more. There is another model of a home-built exhaust pipe piece that someone designed that also involves some vinyl tubing and some copper pipe and some fittings. I may make this. But for now, check this out.